Hello everyone. Have you ever wondered how structural engineers decide the depth of a beam even before starting detailed calculations? In this video, I will explain how to decide the initial or approximate depth of an RCC beam using IS 456 code provisions along with practical thumb rules followed in real engineering practice. Let us begin. Before starting the detailed design of a beam, engineers must assume an initial depth. This initial depth helps in controlling deflection, reducing repeated trial and error during design, saving time, and ensuring that the beam remains safe and economical. The depth of a beam mainly depends on the span of the beam, the type of support condition, the loading acting on the beam, and deflection control requirements. As the span of the beam increases, bending moment and deflection also increase, which means longer spans require deeper beams. Now let us understand what IS 456 recommends. As per IS 456, Clause 23.2.1, basic span to effective depth ratios are provided to control deflection. For a cantilever beam, the effective depth is equal to span divided by 7. For a simply supported beam, the effective depth is equal to span divided by 20. For a continuous beam, the effective depth is equal to span divided by 26. These ratios give the effective depth of the beam, not the overall depth. Let us understand this with a simple example. Assume a simply supported beam with a span of 6 meters, which is 6000 millimeters. Using IS 456, the effective depth will be 6000 divided by 20, which is 300 millimeters. So the approximate effective depth of the beam should be around 300 millimeters. Now remember, effective depth is not the total depth of the beam. To get the overall depth, we need to add clear cover and half the diameter of the main reinforcement. In practice, the overall depth is usually taken as effective depth plus 40 to 60 millimeters. So in this example, the overall depth will be approximately 350 to 370 millimeters. In real-life practice, engineers also use thumb rules for quick estimation. For residential buildings, beam depth is generally taken as span divided by 12 to span divided by 15. For commercial buildings, beam depth is often taken as span divided by 10 to span divided by 12. For beams carrying heavy loads, greater depth is required. These thumb rules are used only for preliminary estimation and must always be verified during final design. Now let us talk about deflection control. Deflection is a serviceability limit state, and beam depth plays a major role in controlling deflection. If deflection exceeds permissible limits, engineers may increase the beam depth, provide compression reinforcement, or modify beam continuity. Among these options, increasing beam depth is the most effective and economical solution. Now let us discuss common mistakes that should be avoided. Do not use the same beam depth for all spans without considering span length and loading conditions. Do not ignore architectural constraints such as flow height and false ceiling. Do not assume beam depth blindly without checking deflection requirements. Always remember that initial depth is only an assumption and must be checked during final structural design. Let us summarize. Initial beam depth is required before starting the design process. It is based on IS 456 span to depth ratios. It depends on span, loading, and support conditions. It helps in controlling deflection. And it must always be verified during final design. If you found this video useful, please like the video, share it with your friends, and subscribe to the channel for more civil and structural engineering concepts explained in a simple way. Thank you for watching, and I will see you in the next video.